Greetings, class, and welcome to Module 9 of 4670. Today, we're going to talk about cloud virtualization and security of both of these areas. So let me share my screen. We'll also go and dive into a demo of Splunk. There we go. So the cloud virtualization security is all about how can I best put this? A lot of it's about shared responsibility and how we can get more for less. So from the text, what we're primarily going to focus on is the importance of enterprise concepts, virtualization, cloud computing concepts, and how cybersecurity fits into the cloud. This is done through governance, risk, and compliance, and we'll look at a couple different models for standardization of security in the cloud and what frameworks that they may fall under. All right, so straight definition on computing, on what computing is, cloud computing, I should say. Model for enabling ubiquitous, convenient, on-demand access of shared resources. These are configurable. They can pertain to items such as servers, storage devices, ancillary platforms such as load balancers or routers. They have to be rapidly, or have to have the capability to be rapidly provisioned and released with little management or effort. So in that, think auto scaling groups, virtual load balancers, other things in AWS such as Elastic Beanstalk that you can have these capabilities of flexibility. So why the cloud? Well, why not, right? It's easy. Little upfront cost at all. You can start with your own credit card and $20, right? And have a web presence next to immediately. It's elastic and scalable, meaning that you can expand and contract as demand hits your site or leaves your site. It's measurable. So with on-prem solutions, you have to buy a lot of extra in order to get the metrics, the data for the analytics. That's all built into the cloud. It's one of the beauties of working with cloud providers like Amazon and Google and Microsoft is they want to know your stats too, so that they can help you in expanding, because if they help you, if you expand, guess what? They make more money. And of course, it is all about agility and flexibility as you need it. So two important concepts here is where the concept of expansion. Do we expand horizontally or vertically? Well, we'll take the latter first. Vertical scaling or expansion is where we put more stuff into the same box, right? More processor, more RAM, more storage. And horizontal scaling is where we take our current platform and we multiply it based on needs. So vertical scaling is really good for certain situations. Probably the most common database. You have a database, it's growing, you're getting more customer information, you need more storage, more RAM, it might be searched more often. You don't split that database up, right? So it has to grow vertically in order to meet demand. Web services, on the other hand, if you keep getting more hits and more hits and more hits and more hits, that's going to overload a server eventually, right? So instead of having that one server get overloaded, you make a duplicate copy of it and you load balance it so that multiple hits, instead of hitting one server, they hit multiple servers through that load balancer. And as you get more hits, you divide up and you get more load balancers, and you look at geography and things of that nature to where, okay, maybe I need to have a POP, a point of presence, for a specific geolocation, because I get more hits in that geolocation than I do in other parts of the world. So those are components that all pertain to horizontal scaling. So roles within the cloud, there are several, and this is all encompassing. So this is providers, servicers, customers, platforms, etc. Cloud service providers, they're the folks like AWS and Google and Azure. The consumers are the end customers. The partners could be folks who sell product through the providers to the cloud consumers, you, the customer, who's building your presence in the cloud. They could be anything, anybody, Cisco, Palo Alto, Checkpoint. Those are just a few that may sell items such as virtual firewalls that you can use in the cloud, or virtual intrusion detection systems that you can use in the cloud. Cloud auditors, this is kind of new. These are auditors. Auditors been around forever that audit your cloud operation and tell you if you're following best practices and help you from the business management side of cloud. And the cloud carriers are the folks who basically provide the data center services or telephony services or telecommunication services. So there are different service models, and this came around before. This is like the old school way of thinking of this, before cloud providers. Infrastructure as a service, platform as a service, software as a service. So infrastructure as a service is where we would have providers that just rent out a rack of equipment, depending on what you would want in that rack. 5 servers, a router, a firewall, a switch to connect everything up through, who knows, right? But you can kind of, like ordering off of an a la carte menu, pick this stuff, and then you pay that service provider X number of dollars a month, and that stuff is yours to use. They may have add-ons like bandwidth amounts, hands-on services, in case you have to replace something like a hard drive, etc. Platform as a service is more attuned to what we see in traditional, or contemporary, I should say, contemporary cloud providers like AWS, where you can have an entire platform that you use to set up your business. Elastic Beanstalk is a great example of platform as a service. This gives you the EC2 instance or server, the storage, the EBS storage, the long-term object storage, S3, backup components, load balancers, etc. So that's a platform as a service. Software as a service is where you would have things that you just access in the cloud and you use. A couple good examples of this might be Microsoft Office 365. Here, one sec. Here, we will have our application in the cloud, and we go to the cloud to utilize that application. You guys use this probably every day with your student email, your student applications, etc. In the commercial world, Salesforce is a great example of this. QuickBooks is a great example of this, where the software is housed in the cloud and the user just goes and accesses it through a browser and does their work. So accessing SaaS is usually done through a thin client. Now, this is evolved to where we can just use a browser, but we may be using a web-based VPN to get to it. It depends on the service. QuickBooks is a great example of this because they have a browser-based service, or for a nominal fee, you can use their thin client and log into their data center and have that additional sense of security. Lambda is AWS's function for creating services on the fly through code, right? Our infrastructure through code is what it's commonly referred to as. Here, you can set up any kind of environment that you want on the fly, administrate it through code, and even be able to pull information out or do common tasks through Lambda. So commonly, what I use Lambda for from a sysadmin side of the house is I would set up Lambda scripts to go and do backups of my EC2 instances, prune my EBS databases, transfer information from my S3 objects or S3 buckets with my objects in it to different locations, or grab what I needed out of them if I'm dumping stuff to S3 as part of a process. Very, very, very powerful. Automation is the way to go. This is how the IT industry has really begun to do a lot more with fewer people. Okay. It's a service, so it can be applied to many different aspects of cloud computing. So the public cloud is probably what you're most familiar with. So this is the one anybody can use. I can go into and create my AWS account, create an EC2 instance, log into that instance, create a web platform off of it, create another EC2 instance where I keep my customer database, create another EC2 instance where all my product cataloging is, set up a shopping cart on one of them, and bam, I'm in business. So that is the typical public cloud. And as I get more hits, I can expand it very dynamically. Private cloud is where you have all that, but you pay for everything up front and you build it yourself and you have it in your own data center. Hybrid cloud is where you have kind of a mix between the two. And you see hybrid cloud a lot of times where companies and organizations that are moving to the cloud set up a virtual private cloud or a virtual private connection, and okay, so moving on, community cloud is something you don't really come across too much, but a good example of that might be something like a public library, where you have community cloud where you can share books or ebooks or something of that to that extent. AWS has a hybrid cloud capability. Typically, how you set this up is through a virtual private cloud, and you have a VPN connector to your premises. And then you can share, you set up your networking correctly, you can share information between the two clouds or migrate data between the two clouds. This is typically done in the migration process from traditional on-premise data center solutions to the cloud. AWS, as well as Amazon, as well as Microsoft, as well as Google, have this concept called a shared responsibility model. And in the shared responsibility model, this is where they set forth the guidelines of who does what. So, for example, your cloud provider are going to be responsible for hardware. They're going to be responsible for replacing hardware. Like if a hard drive dies in a server, they are the ones who replace it. They're responsible for electricity and the physical plant and cooling and things like that, where the customer is responsible for all of the logical pieces of this puzzle, your own data, your logical security, your configuration, your data backups. You're responsible for those pieces. And it's different as they break it down between IaaS, PaaS, and SAAS. But from a cloud perspective, you really have to look at who has the capability to touch what. So Amazon does not have the capability to go into your system with an administrator or root account, for example, and do anything. You don't have the capability of going to a AWS site and getting into that site and doing anything with their hardware. So that's the way you kind of have to look at the shared responsibility model. Standards and guidelines. Well, this basically states that any standard or guideline or guidance compliance that you follow normally, you would still follow it in the cloud. PCI, HIPAA, SOX, those things you would follow along in the cloud. Moving on, here we see kind of a typical audit tool that is used to measure cloud standards and guidelines. You would see this by used by something like a cloud auditor. Very similar to regular IT auditors and what they leverage for control checks. So let's shift gears and go into virtualization and talk about hypervisor types. So hypervisors are the piece of software that sits on top of the operating system or in line with the operating system and controls sub-operating systems or controls flow of information between the operating system and the hardware. Type 1 hypervisors are where you have the hypervisor sitting right on top of the hardware. So a good example of this might be VMware's ESXi, where you have operating systems or VMs that are on top of that hypervisor. Type 2 hypervisors are where you have your hardware and operating system, your hypervisor, and then your VMs. So a good example of this might be Microsoft Hyper-V or desktop virtualization, which is what we see with VMware Player or VMware Workstation. So a little bit about the components of cloud services. Virtualization is what makes the cloud work. Provisioning virtualized servers, or what are commonly called EC2 services, Elastic Cloud Compute, that's where you get the EC2, is very simple. It's streamlined. And you can pick a lot of different variables, for lack of a better term, as to how you want to have that virtual machine operate. So you can choose the processor type, the amount of disk space it has, the amount of RAM it has, the type of network it's going to be on. And the more beefy, for lack of a better term, or the more gusto or the more horsepower it has, the more processor it has, the more RAM it has, the more disk it has, the more expensive it's going to be. And typically these are priced out on a per second or per 10-second or per minute basis. It depends on the cloud provider. It makes it sound really cheap, but trust me, it adds up over time. Connecting to these virtual services in a cloud provider is done one of two ways. So on Linux and Unix boxes, it's done by SSH. So what you'll do is when you set these servers up or these instances up, you will create an SSH key. You'll download that SSH key, and then you will use that SSH key to initially log into the server. The root login is typically generic, but if you don't have that key, you can't get into it. And you always change the root password when you log in. With Windows services, it's a little bit different. You have a virtual server instance where a randomly generated password typically is created for you. And then it's a one-time use only. So it acts as a one-time pad, if you remember that from talking about cryptography a week ago. And you change your password, right? And then it's on you. So it only works for that first initial login, and then you change your password. But with RDP, remote desktop. That's how we have to interact with Windows servers for the most part. Now, can you set up a Windows server, core services only with remote PowerShell or with SSH? Yes, you can. Of course you can. Does it typically set up that way? No. Can you set that up within AWS or Google or Azure? Yes, you can. It depends on how you provision the server up front. Okay, so let's talk a little bit about storage here for a minute. Cloud storage comes in two flavors, block storage and object storage. So again, reverting back to my AWS knowledge, block storage is where you have something like EBS, Elastic Block Store. This is a hard drive that you create, not part of the operating system that you do on an EC2 instance, but like a second hard drive. And then you can attach that EBS to a server, or 2 servers, or 5 servers, or however many servers you want to. It's like almost like a NAS or SAN LUN. Object storage is where you have storage as a service. Think AWS S3, simple storage service, where you put objects in it. Now, what is an object? An object is anything that you would normally put on a hard drive: a file, a picture, a document, a video, whatever, right? It's meant for object storage. Now, can you put a database file in there? Yes. Can you have that database file interact with an app? No, you cannot. All right. Typically, that does not work. Can you move things to S3 for storage? Yes, you can. Right. But it's there for storage. It's slow. Can you get to it easily? Yes, but it depends on how much speed you want to pull that out of. It's not dynamic. You typically do not use object storage for interaction. There are other types of object storage too, which are typically used for long-term storage, right? So long-term storage would be like an archive, and that would be something akin to AWS S3 Glacier. So you can have, like I said, this is an example of many volumes that's built in EBS, many buckets that are built in S3, and buckets would have would be like a storage area, like a folder, if you will, or a directory, and then you put stuff under it. Can you have subdirectories? Yes, you can. A subdirectory or subfolder would just be another object. Okay, so some key takeaways here on security, especially in cloud. Set your permissions properly. Use that with IAM, all right, Identity Access Management, which we talked about previously, I believe. Consider high availability and durability options. Okay, so in case something goes awry, cyber attacks do happen, all right? Equipment failures do happen, even in the cloud. So distributing your compute, distributing your storage is always a good thing to do. And of course, use encryption to protect sensitive data. Now, I get the argument a lot of times that, well, it's in Amazon. Does it really need to be encrypted? Yes, it still needs to be encrypted. It is not foolproof, right? Data can still leak or have the potential to leak. We've seen this, right, with hypervisor bleed. But it's also just a great idea to encrypt your data at rest. You can do this in EBS volumes, for example. There is a little check mark here, encrypt the volume. Now, couple of rules about EBS encryption, if I'm not mistaken. It's best to do this when you set up the EBS volume. So if you know that the EBS volume is going to be used for storage of sensitive material, check that box. If you're unsure, but you're like, oh, maybe there's, check the box. Okay. You can encrypt after you store data. So if you have data stored in your EBS volume and you're like, oh, wow, that should be encrypted. Okay, go back in, click, check the box. But you typically do this when you create the volume. All right. You can't decrypt it though. All right. So here's an example of Cloud Network Security Group. This acts as a simple firewall for your instances, your EC2 instances, and you can set up based on protocol and port and source and destination address. So typically the destination is at the root, so we don't see that right now. So this would be for an individual IP, an individual host. Think of this like working with Windows Firewall or IP tables in Linux. So this is host-based. And you set up access for whatever port or protocol that you want, including what type of protocol, such as IPv4 or IPv6. In cloud networking, when we set up virtual private clouds, we have to take into consideration where traffic is coming from and where traffic is going to, what subnets are on the inside, what subnets are on the outside, and not duplicating any subnets. That is probably the hardest part not to do. You can change this. They will default to specific networks depending on cloud provider. So be careful of that, because I've seen where VPCs have been set up and they don't work, and you have the same subnet set up somewhere and natting is not happening correctly, and it becomes a mess really fast. You can create EC2 instances with CloudFormation in JSON. CloudFormation is a service that typically AWS developers use, or maybe AWS system operators, SysOps, and you do everything as code. So if you want to set up an EC2 instance, you've got to program what type of processor, hard drive, EBS volume, the network adapter, IP address, or it will default to an IP address, the operating system type, and all these different variables. Now, it's a really great idea to take a AMI of this, a machine image in JSON, or what equates to be a machine image in JSON, save it if you intend to repeat this a lot. So if you're ever working in an organization that is supporting developers, this is a godsend. This will really save and cut down the amount of time that you use administrating for those developers. So a couple things on cloud security. Cloud security has the same concerns as non-cloud security. All right, CIA, confidentiality, integrity, availability, of course. Data sovereignty. There's always questions as, well, who owns the data? If AWS owns the equipment, doesn't the data belong to if they own it? Now, there's gray areas there, but typically this is set forth in the terms and conditions when you sign up for AWS or Google or Azure, and they all state that no, the data belongs to the subscriber, right? Virtualization security and application security are also key pieces here. Virtualization security, if you are worried about things like hypervisor bleed, then you might want to look at private cloud or virtual private cloud, where you have your own hardware that you are using, but it might be in an AWS or Microsoft or Google facility. Application security is still the same problems that we have in a normal on-prem environment. Has anybody gone through the code? Has anybody validated the code? Is the application gone through security testing, stress testing, etc.? And you still need to follow good governance and auditing, continuity, backups, disaster recovery planning, all that. Anything that you would have in an on-premise data center that you managed, you should still have those same controls, processes, and procedures in your cloud environment. Okay, so cloud security controls. Who controls those controls? Well, you can have a lot of different folks that do that. Cloud access security brokers, so who will work with, they're basically like managed service providers, and people who write the policies, or secrets management, who are your SysOps basically. Resource policies could be where do you fall in line with HIPAA or PCI or SOX. Cloud brokers, again, these folks who are kind of like your MSPs or your resellers, they basically have two different types of solutions: inline solutions and API-based solutions. So inline would be something like where I am a broker and I sell you a virtual appliance, like a virtual ASA or a virtual Palo Alto box or a virtual checkpoint box or Sonic Wall box, etc. And that sits in your environment and that gets administrated by me or my team or whomever. And then there's API-based solutions where this is more attuned to the application. So think of a virtual web application firewall, a WAF. That's a great example of an API-based solution. All right, so that concludes lecture. I want to go now and shift over here to Splunk 101. And this is a good example of a room. This is a paid room, so I'm using my paid account for this. And I don't know why Splunk did it, but this is a great example of how to set up Splunk, or initially set up Splunk, and it kind of walks you through the process. So I'm gonna go ahead and start the machine here. All right, and that machine is gonna come up over here on the right hand side. I like how Try Hack Me kind of breaks everything up. I'm gonna pause real quick and come back to it when it's ready. So I'll see you in a sec. So the other thing I wanted to say about using these rooms in Try Hack Me is there's a lot of good tutorials out there, both tutorials that are paper-based and that are videos. So going through the introduction up here after we start the machine, Varonis actually has a good walkthrough video of this room, and I am going to just kind of let him do stuff on that. But they do give you the IP address, which should be 10.10.109.48, the username and password. Even the initial script of when you start the machine, it logs in for you. All right. The next section kind of goes through the navigation of Splunk, how to get into Splunk, which is pretty straightforward. You just put a URL, you open up a browser and you go into the URL, the local URL. All right. They also have links to some cool navigation. What I'll do here to wrap up the lecture this week is I will put a link to the introduction of the author of this and let them do that as the demo. And we will leave you with that. And next week we will talk about Unit 10. So this week, close this out. There's a close button. So this is in module 9, if I'm not mistaken. There we go. You do have homework 6 due this week. So please, 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 please work on that. This is a homework on viewing and running processes in a Windows-based machine. So you can do this on your own Windows machine. If you have a Linux machine, so you can do this on your Kali box as well. But I have you take a series of screenshots looking at running processes based on operating system, because this is something you need to understand for IR as well. So if you're doing incident response, looking at processes is one of the things you're going to do all the time to make sure the bad guys or gals are no longer in the system. Okay, so make sure that you tackle homework 6 this week. And that is about, oh, you know what? I think I goofed. I looked at the wrong class. Nope, I looked at the right class, excuse me, 4670. Oops. So look at those running processes this week. And that's it. I will see you next time in Unit 10. Have a good one.